So we're looking at cumulative frequency, and we had this laid out in an earlier video. It's basically looking at, in case you didn't see it, a cucumber company, and we were sorting the lengths of the cucumbers out. We had 100 cucumbers, and we had 7 boxes. Those boxes are represented here by this column. And the small ones went in the first box along here, and as the boxes went along, the cucumbers got bigger. And we found that we had 5 teeny tiny ones, and then between 5 and 10 centimetres there was 10, between 10 and 15 centimetres there was 15, between 15 and 20 there was 25, between 20 and 25 centimetres there was 30, between 25 and 30 centimetres there was 10, and the real big ones, there was only 5 of those, and we said they were between 30 and 35 centimetres long. We then went to our cumulative frequency here, where we add up all the frequencies, and that tells us how many of the cucumbers we've actually sorted by that time. So I started off by sorting the first box, I sorted 5 of them. I then sorted another 10 of them, so that was 15 in total, right the way through till when I'd sorted all of the 100 cucumbers, the whole boxes of the whole 7 boxes. We then plotted it on our cumulative frequency chart that we have here, graph that we have here. And on the cumulative frequency graph we've got, you can see down the side, there's our 100 cucumbers, and along here, there's the length of those cucumbers. Now, this curve that we have here is called an ogive, O-G-I-V-E. And you can see this part here is a lot steeper than this part here, which is quite shallow, and this part at the top is very shallow. And you can imagine, if this were a real cucumber company, we would have a lot of cucumbers that were kind of cucumber-sized, somewhere in the middle. And because we have more there, 30, 25, in the middle, that becomes a lot steeper. And that's what gives it this distinctive cumulative frequency curve. From this cumulative frequency curve, ogive, we can actually now pull out some more data and interpret this some more in terms of looking at a median. That means a value that we're giving, a median value that we're giving to the cucumbers that we sorted. And we can look at upper and lower quartiles too. I'll explain those in a moment. So I'm going to start with median because it's kind of the easiest one to get our head round. And median sounds a bit like medium, in the middle. And of course, in the middle of 100 and 0, we have 50. So we start at 50, and I'm going to draw a line along from 50 to where it intersects with our curve, our ogive. From there, I'm going to come down. And you can see I'm crossing the x-axis at around 19, shall we say? So we can say that's going to be the median. We can label these in a moment. Now, the lower quartile is where the first quarter of our cucumbers occur. Now, we have a little bit of a problem in that we can't say, okay, where were we when we were 25 cucumbers into our counting? Because we never actually got to 25 cucumbers, we got to 30 here. So we know that the length is somewhere not too sure, and that's why we're using the curve. Because I can say the lower quartile, i.e. the first quarter, the first 25 of those cucumbers that we measured and sorted come somewhere around here. And we say the lower quartile, what do you think, 13? I think so, about 13 maybe. Can you guess where the upper quartile is going to be? Yeah, you guessed it. Between the top half here, we've got 75. And of course, that's 1 quarter, 2 quarters, 3 quarters, 4 quarters to get all of them. 3 quarters of 100, 75. Our upper quartile, nicely underlining the word ogive, you'll notice. How does that look? I think it looks good. You're going to come down from there, exactly the same as we did for the median, and exactly the same as we did for Q1, the lower quartile. We've now achieved the upper quartile. So I think it's about time that I wrote some notes on here. I'm going to say that this here is Q1, our lower quartile. This middle line, the first one we put in, you'll remember was the median, sometimes referred to as Q2, which is also the median. And yep, you guessed it, upper quartile, Q3. And from this, you may start to have seen this before, I don't know, but we're moving into where we can actually plot a box and whisker plot. Now, box and whisker plots are very useful for displaying information in a way that you don't have to necessarily look at the numerical data, but you can immediately make comparisons between two sets of data, basis the box and whisker plot. Now, as you can see, I've drawn a box here. Not too many whiskers at the moment. And the whiskers come from our range. What was the smallest one? What was the largest one? Now, in here, we've actually always used the upper end of each of those ranges. So if I had maybe some tiny little cucumbers around 3 or 4 centimetres, we still say they were in the 0 to 5 box, and we always use the top of that range. So I'm going to come down here, put a line there, 5, move that across. Come up to here, top of our range, 35. And there are our whiskers. You can also see from this that in the middle we have marked the median. So we can see the range, which is between here and here. The range in this case is the upper limit of that range, 35, subtracting the lower, which is 5, so we have a range of 30. We can see our median, 19, with a lower quartile, 13, an upper quartile, Q3, of about 23. So hopefully from there you can see that we have taken our data, we sorted our cucumbers into our 7 boxes, we then put that data into the frequency table, we then did the cumulative frequency, which we can plot. You can see how steep this was here, and the steep area in the middle is because most of the cucumbers fell in that range within the middle there that were kind of cucumber sized. And then the extraordinary large ones and the teeny tiny ones made this a lot more shallow. And from that, we've produced a box and whisker plot from the ogive curve. Okay, so there's one more thing that I want to talk to you about here, and that is the interquartile range. The interquartile range is this range here, and we can actually give that a figure and calculate that. And the interquartile range, the interquartile range equals Q3 subtract Q1. And we can look at, actually, we can do that now. Q3 we said, about 23. Subtract Q1, about 13. 23, subtract 13, 10. So I can say the interquartile range, the IQR equals